Hello everybody and welcome to our webinar. Today we are going to talk about expanding possibilities, DEWETRON's new analog output board. But before we start, I would like to explain some organizational things. On your right side of the webinar tool, you can see a chat. This chat is used so that you can ask us questions. Those questions are anonymous and only me and my colleague can see them, nobody else. We will answer those questions at the end of the webinar. There are also some handouts available for download during this webinar. They are directly below the chat symbol. So let's start. Today, I am joined by my wonderful colleague, Verena Niederkofler, know-how expert and application engineer here at DEWETRON. Hello, Verena.
Hi, Ivica.
Hi, nice to have you on the show today. My name is Ivica Baresic. I'm sales and business developer here at the headquarters in Austria for DEWETRON. So the presentation and the webinar today are split into two parts. The first part is me presenting the analog outboard with some very short slides, and then I'm going to hand over to Verena, who is going to do a live demonstration with our amazing software Oxygen. So my first part, just some words about DEWETRON. DEWETRON has 120 employees and the headquarters is here in Austria. We have 3 subsidiaries and are active in over 25 countries. And our expertise is shown by the numbers. We have 25,000 measurement systems and 400,000 channels yet out in the market. So let's talk about the analog output and the known solution. So that's nothing new for DEWETRON until now. Let's talk about the DV1 solution, the known solution until now. And that was that we used the so-called DAQP modules, which have been put into a so-called rack, which generated then 16 conditioned analog output signals. There are certain limitations to this solution, which is a fixed channel mapping. You have not been able to change the mapping of the channels to the analog output afterwards, and there has been no current output. Voltage output, they have been defined by the factory, either 5 or 10 volt, and this was fixed and not changeable afterwards. Very important, no mathematical operations have been able, so only monitoring conditioned analog outputs, and no function generator and no stream output is possible. And what these two things are, we are going to explain during this webinar and of course also show you in the live demonstration afterwards. So what's the solution right now? We have for our DV3 series a so-called analog output Tryon module, which occupies 1 slot and has functions like the function generator, a constant output, and a stream output. Now, if you would like to have addition to these 3 functions, the monitor output and the signal conditioning, like in the DV1 series, you just have to add a so-called Tryon multi-board, which are 8 analog inputs, and those analog inputs can then be used for monitor output or for math output. And of course, functions, the 3 functions from the standalone module are here available as well. Let's talk about the Tryon analog output facts. We have 8 independently programmable isolated output channels, and the output ranges now are able to be changed by the customer or by the user himself whenever it is necessary or needed. It's done with the software, and we have now a current output function as well. We have 8 analog outputs on the D-sub-37 connector, the broad connector on the analog output module. And we have additionally to that 3 BNC connectors for the channel 1 till the channel 3 as analog outputs as well. On the board are 8 digital inputs and 4 digital outputs included as well. So further facts, the channels are isolated with 350 volt DC channel to channel and channel to chassis. and the output accuracy is astonishing 0.02% of reading. The most important thing that I would like to mention with the analog output module now is that we have two different modes. We have a high-speed mode with 2.5 megasamples per second, which allows us a latency of 5 microseconds or less. It has only a 16-bit DAC resolution. If you need a higher resolution, we have the high resolution mode, which allows a 32-bit of resolution, but with a lower update rate, and the latency is 100 microseconds or less. When we talk about the functions, I would like to highlight one thing out. Monitor output like the DV1 series and DAQ models is again possible. Direct condition signal output of a channel of the Tryon multi-module, which is in combination with the Tryon analog out if needed. What is more important to know is that we have now math output possibilities as well, where we can, with mathematical operations, calculate two channels together, which is also important to mention is that we have an average and an RMS possibility as well. So we can take one channel, calculate the RMS value, and also output this as an analog output. The constant output is also necessary to mention with minus plus 10 volt or minus till plus 30 milliampere, which is already part of the function generator. We have pre-programmed sinus, rectangle, and triangle where you can define everything. We will see it later on in the hands-on. And you can also use custom waveforms, which is so important and necessary often out in the market. One highlight is the stream output. You can now output channels of previously recorded data files if necessary to simulate any measurements that you have done prior to that. And this is such an amazing additional feature. So that's about the functionalities. And as I said, I have just some short words about it. We are going to jump to the oxygen demonstration. Verena is going to take over. Verena, I'm going to hand over the moderator to you.
Please.
Do you want to, Verena, to be the moderator? Of course, I would like Verena to be the moderator. So Verena is going to do the live hands-on with our amazing Oxygen software and show you the Tryon analog output board and the functionalities. Verena, the stage is yours.
Thank you very much.
You're welcome.
You should be able to see my screen now.
Yes, perfect.
Okay,
yes.
Perfect. Thank you. Okay, so let's get started. Here you can see oxygen, like my colleague just told you. We can see the measurement screen, and here I prepared a picture to show you how I connected the sensors or the function generator. So I have the combined A-out board here and another voltage board. I have a function generator next to me, and I have connected two signals to the first two channels of the multi-board from the combined A-out board. As a third signal, I have a tuning fork, which I have here. So it has strain gauge on the side where you can measure the strain on the strain gauge, just to show you like another signal. As you have seen in the presentation before, the first three channels are available on BNC connectors, and I have connected those to the voltage board so we can measure the signal back, which are output here, just to show you also. Okay, so let's start with the first mode. I have prepared a measurement screen for each mode to show you what we are going to do. So for the first mode, the monitor output, I have connected two signals from the function generator, and I have the tuning fork connected to the third channel. These are mapped to the BNC connector of the analog output board, and we can also, this signal will be output, and we will measure it back on the voltage board here. Okay, so I will open the data channel list. And as you can see here, I have the multi module, and here you can see the A-out module. And down here, below all the digital channels of the A-out board, we can see the voltage board. Okay, in order to use the monitor output mode, I will open the setup, the channel setup of the first channel of the A-out board. And here I can see the mode. I will select monitor output mode. Here I can also select the range, the output range. So like my colleague just told you before in the presentation, we have different output ranges available from plus minus 10 volts or current output. And here I can also select the high speed or high resolution mode. I will show you the difference in these two modes a little bit later. First of all, I will choose the source channel here. So the channels are not hard mapped to the channels of the A-out. So I can also select, for example, the third channel here to be output on the first channel of the analog output board. I will just go with the first channel of the multi-board, click OK. And here I have also the option to output either the actual value, an average value, or an RMS value of the signal of the multi-board. If I select average or RMS, I have the option to choose a window type, moving or fixed window, and I can select a calculation window which I would like to use. So I have the drop-down list or can also enter something individually. I will select the actual output mode now, and then here I can see the scaling information. If I have a higher signal, like for example 30 volts, it will be conditioned to plus minus 10 volts here, and I will see this information in the scaling information here. Okay, then I will go to the next channel. So now I'm on the second channel here. I will also choose the monitor output, and it automatically chooses the second source channel from the multi-board. But of course, I could also select either channel of the multi. Okay, so I will show you on the measurement screen. So here I have a recorder with these are the my original signals. And here I have the signals which are measured back. Just zoom in a little bit. Okay, I will freeze the screen so we can actually see something. Okay, as you can see, here are the two original signals, and here I have the signals which are measured back. So these are just the same. If I put everything in one recorder, they will just overlap. I'm not sure if you can really see that, but the color changes of the signals. So, okay. The other thing is, for example, the tuning fork. So I can also select, for example, the tuning fork here to be output on the second channel of the analog output board. And now I will return. And I will choose the tuning fork here, the original signal, and the second signal of the analog output board, the second channel. And if I hit my tuning fork on the table, I just need to zoom out a little bit, scale it. Also here. Okay. So as you can see, this is the original signal from the tuning fork, from the multi-board, and this is the signal which is output by the analog output board. And if I hit the tuning fork, you can see it's the same signal actually. Okay, so So much to the monitor output mode. As the other thing I wanted to show you for the monitor output is also the difference between the high speed and high resolution mode. So I will select the first channel of the analog out. Here we will select, we have the first source channel where we will add a sine wave. Okay. And we have the high speed mode here. For the second channel, we will select the same signal. So also the first channel of the multiboard, also the same sine wave, but instead we will select the high resolution here. Okay, so if we switch, we can see the only difference is the output mode. Like my colleague already told you before, the high resolution mode has a output rate of 500 kilosamples per second, and the high speed mode a output speed of 2.5 megasample per second. So here I will just make this a little bit bigger, and we will choose both signals here, both channels, and I will zoom in to show you the difference. So from outside, there's not much difference because the latency is small anyways, but I will zoom in here. Oh, wait, I selected the wrong one. I need to measure it back here. Okay, perfect. So this is not the actual latency which you see here, but I just wanted to show you that there's a difference in the latency between the high resolution and high speed mode. So the first one, which we measure back, is the high speed mode. So that's a little bit faster than the high resolution mode for the second signal. So just as I said, this is not the actual latency, but I just wanted to show you that the high speed mode is even faster than the high resolution mode. Okay. So that's it for the monitor output. So we will come to the second mode and change the measurement screen for the constant output. So the constant output, there's not really much to say. The constant output also works with only the analog output board, so you don't need the combined board to use this mode, as you can see here. So the multi-board doesn't have an effect on that mode. In order to use that, I will switch the mode to constant output, and here the settings change. I can use the slider to define a value, or also put a value in by myself. We don't need a source channel, so that's just a constant output. And as we can see here, this is the constant output which is used on the channel. And if we go back, we can see this output of the 5.6 volts, which is output here. That's actually it. So there's not much to say about this mode. If you have any questions, please let me know. Okay, so let's move on to the math output. Here, I will again use my function generator and my tuning fork, and it works in a way that I use two channels which will be used for a mathematical operation, and they will be output on one of those output channels. That's what I defined since I have connected those on the voltage board. So I will change the mode on to math output. Again, I could adjust the range. I could adjust the output mode here. And here we can see that I can select the source channel A and the source channel B. So I have again available all the channels from the multiboard. I can select each channel. So let's select the first channel of the multi. and the second channel of the multiboard, and I will just change the signal from the function generator to a square and to have a lower frequency so that we can see something better. So we have a sine and a rectangular waveform with 1 Hertz. And now we can choose here the math operation, which is we can add the two signals, subtract one signal from another, or multiply the two signals. I can just only add this, and I can see here the result also. I again have the option to output the actual, the average, or the RMS value. As you can see, for the multiplication, I have the input range would be 100 volts because the first signal and the second signal have a range of 10 volts, and which this is rescaled to plus minus 10 volts here. As a second option, I can not only use the function generator here, but I will use the strain gauge, the tuning fork. So I will use the tuning fork as my first signal, and as the second signal, my rectangular waveform here, and add those two signals together. And as you can see, again, if I press the tuning fork together, the signal will be modulated here. Okay, so I will show you the result on the measurement screen also. So first, the two original signals here and the first output value. So I will freeze the screen. And here you can see the sine wave, the rectangular signal, and this is the multiplication. Maybe I will change the color so you can see it a little bit better. This is the result of the multiplication of those two signals. The other two signals would be the tuning fork and my rectangular signal. And here on the second, we have the output, the result of the I think we added those two signals, yeah. Okay, so if I press the tuning fork together, you can already see that the green signal is the tuning fork, just the tuning fork alone, and the other, the orange, which is the original, is the red one, and we will make this blue. So the blue signal is the result. So if I press it together, you can see the tuning fork signal. The red one is the rectangular signal, the original, and the blue one is the result if we add those two together. If I hit the tuning fork and I'll freeze the screen, you can also see this result on the screen here. Okay, so that's it about the math mode. As you can see, there's not that much to explain for each mode since they're very simple to use. Okay, so we move on to the function generator. As you can see again here, the function generator can be used with just the analog output as a standalone module. The multiboard is not needed to use this mode. I will just change the mode again to function generator. I have the same options available, just not the range. I can adjust that here. I can either select a waveform, sine wave, square, or triangle here. With the available options, I can select the frequency, the amplitude as either the voltage or current output. I can say if that should be peak or RMS value, which is calculated then. I can select an offset or also the phase. As a second option, I have the custom waveform store. So that was the part where my colleague told you that you can load an individual waveform. So for the first channel, we will leave the sine wave here. And for the second channel from the analog output board, we will also use the function generator, and we will use the custom waveform store. So as you can see, one waveform is already loaded. It's really easy to use. So the waveform can be defined in a CSV file before. So this like the step waveform, I defined that before in a CSV file, and then you just save it. Each sample should be one row. You save it, and then you can either drag and drop the file here, or I click on this button on this field. And here you can see I have different waveforms, different patterns already available, which I just load. And then they are saved. This is the same one, so we just choose this one. And then we have these 3 patterns available in my custom waveform store. Up to 4 patterns can be saved in here. They are also available for all the other channels, so not only for the second channel, but if I close this and I open the setup from the 8th channel of the analog output board and I choose the function generator, I can also see I have the same options available here. So these are actually saved for all the channels. So I will go back to my second channel. And in order to select those, to output it, I can either use the drag and the drop down list here, select a waveform, a custom, or I can also click on these fields here. I again have the options available, select a frequency, for example. I can increase the amplitude and define offset and phase if I would like to. Okay, so that's it. So we go back to the measurement screen again in order to show you. So here is the sine wave, which will be output, and also my custom waveform, which I defined before. As you can see, it will just be repeated all the time with the according frequency. All right. Then let's move on to the last mode, which is the stream output mode or the file replay. I will change to the last measurement screen. And here you can see the stream output mode or the file replay can again be used with only the analog output board. The multi-board is not needed in order to use this mode. For the stream output mode, we need a recorded file since you're able to stream output a channel or multiple channels from a previously recorded file. This can be, for example, used for like a test drive can be very expensive. So you can have that once and equip your device under test with multiple sensors, do your recording, and then you can go back to your test bench and you have the previously recorded signals there, and you have like real conditions where you can perform your tests on. Okay, in order to do that, we need a recording. So I will just do that now. So we have, for example, a tuning fork. So just to show you here, all signals will be recorded now. So we will start a recording. I will just hit the tuning fork a couple of times, press it together, and I will stop the recording. Perfect. Okay, so now, in order to use the stream output mode, I will go back to my analog output settings and I will select stream output here. All the options disappear since we can do all the settings in the according instrument. And I will also use the second channel for the stream output. We'll also change this mode here, and then I will just close the settings and come back to my measurement screen. As my colleague mentioned before, we have an additional instrument available for the stream output, which is called the output channel instrument. I will just drag and drop this out here, make it a little bit bigger. And now I place the two channels where I selected the stream output mode from the analog output on this instrument. It is possible to select more channels in one instrument, but as you can see, if I have selected a channel from the analog output board where I have not selected the stream output mode in the channel settings, I will get a warning, and I have to select for the third channel, for example, here also stream output in order to use the channel for stream output mode. So just as a notification here. Okay, so we have selected the output channels. Now we have to select or open the instrument properties of this instrument, and we can select or browse the data file which we just recorded, which is this one. We import it and we can see the status is open. And now we can see the two channels here which we have put in the instrument. And we can click on this button of the channel list. So this is the channel list from the data file which we have the recording from. So we have the recorded file, and we can select a channel to be output on the first channel here. So I will select the tuning fork, the signal, and for the second output, I will select my custom waveform, which was the second output channel, I think. Yes. Okay, perfect. Okay, so here we can see the signal from the tuning fork is a little bit small. I have the option available to put a factor, which is like a gain, which I can use, for example, 10, and this will just be to use that here. The other thing which I have available is the offsets. I can either use the offset on this field here and move my signal up and down. As you can see, the offset also changes to apply an offset on my signal, or I can just put it in here individually. This is my second signal. I have the same options available here. And to stream out those signals, I can just press start, and those signals will be streamed out. In order to measure that back, I have connected those two first channels to the voltage board, which I will put in here now in the other recorder, so you can see what happens. So I will just press start in the instrument, and as you can see, the signals from both channels are output here once I press start. Once this is finished, it will stop. In order to loop the playback, I have to check this box, and then I can press start, and it will repeat the same sequence, the same output again and again. If I press pause, it will pause the output, and if I press start again, it will start from the location where I pressed pause at. If I press stop, it will stop and jump to the beginning. Then I also have the option to not output the whole sequence, so the whole recording, but only a specific part. I have this stop and start cursor on the bottom here, which I can just drag and drop to a specific part. So I will use this part, and I want to say that I only want to output this part again and again. I press start again. And now, as you can see, only this specific part is output on my channel. If this is not so exact, since I don't see the timeline, I can also click on it and define an exact time. So for example, from second 3 to second 6, I want to output my stream here. And only this part will be output. If it should be output only once, I can deactivate this checkbox and it will be only output once from the beginning. Okay. That's it actually from my side. If you have any questions, just let us know so we can answer them.
Yes, perfect. Perfect. Thank you, Verena, so much for your demonstration and presentation of the analog output module and option. And the options that we have now, it's so simple, and therefore it doesn't take so much time to present it. I don't see any questions so far in the tool. In case there have been some questions and the tool doesn't show them, we are going to answer them in the afterward after the presentation. Yeah. So thank you for listening. If you have any further questions, feel free to contact me and my colleagues. Our contact data is available on our homepage where you registered or on social media. If you know colleagues or people who would be interested in this webinar, we are going to have further webinars in the coming days. And we are going to put this webinar on YouTube after the live sessions as well. So thank you for watching. Stay online, answer some questions after this webinar. We're going to ask you some questions which helps us to get better. And again, thank you for watching and see you at one of our next webinars. Bye-bye.
Thank you. Bye.